Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amar Nasrullah bin Ahmad Nawawi. For the first, I would like to presentation about the transportation problems. For the transportation problems, we choose transportation models. For the transportation models, it's a linear programming problem that deal with the distribution of goods from several supplier to several consumer. In this topic also have three methods can be used in initial feasible solution, which is northwest corner method, and then minimum cell cost method, visible approximation method. Next, for the method for solving the transportation problem, such as a modified distribution method, and then secondly is a stepping stone method.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Asraf bin Muhammad Aziz. So I will present about the question 1, which is transportation problem question. Question asks define the minimum of transportation cost using the northwest corner method for the initial feasible solution and to find the optimal solution for this problem. The northwest corner method, we start from the top left of the table, which is on the first column of the warehouse, one of the first row of factory. Okay, first the demand show for the warehouse 1 is 12 unit and can be complete by getting supply from the factory 1, because the factory 1 has a supply amount of 40 units. So warehouse 1 will not get any supply from other factories. Next, we will look at the demand warehouse 2. The first cell of warehouse 2 is on the top left, excluded the cell that has been filled in. The demand needed for warehouse 2 is 15 unit and it can be completed and supplied by factory 1, because factory 1 has a balance of 28 units after subtracting with 12 units. Okay, next we look at warehouse 3. The demand needed for warehouse 3 is 20 unit, but the balance that the factory 1 has only 13 units. Warehouse 3 has to get the supply of 7 unit from the next factory, which is factory 2. Okay, so for the warehouse 4 and warehouse 4 will not get any supply from factory 1, because they are already out of supply and need to get the supply from the other factory. And the demand of warehouse 4 is 15 unit, but the factory 2 only has the balance of 2 units. So warehouse 4 need to get the balance of the 12 units supplied by the factory 3 in order to complete the demand needed by the warehouse 4. While for the warehouse 5, they will get the supply from the factory 3 of 8 units, only due to the balance after subtracting the demand needed by the warehouse 4. And the balance of the demand, which is 10 units of warehouse 5, will be supplied by the factory 4 to be completed. After all the demand and supply has been completed, we will calculate the total of transportation cost needed under the northwest corner method. So after calculating the total cost of transportation cost is 922, but this cost is not the optimal and minimum cost, and the optimal solution will be needed to know whether the cost calculated using the northwest corner method is already minimum or it can be reduced more. Okay, so the next step is to find whether the cost can be minimized using an optimal solution, which is the modified distribution method, and also the stepping method. The table used in the modified distribution method is the same as in the north-west corner method, but has a slightly different that has been added, which is the V and VG amount and UI amount. So in the table, extra hand column with UI symbol and the extra top row with the VG symbol represent a value that must be computed for all cells with allocation using the formula of UI plus VG equal to Cij. So there are 8 cells with allocation and need to solve the equation using the formula mentioned just now to find the value of each UI and VG. After calculating the value of UI as shown in the table, which is U1 to U2 equal to -3, U3 equal to -3, and U4 equal to -2. As for VG, the values are shown in the table, which is VA equal to 13, VB equal to 9, and VC equal to 15, VD equal to 15, and also V equal to 12. After that, we will calculate the values for the empty cell to find whether we can minimize the transportation cost using the stepping step method. So the result of the calculation for the empty cell shows there are negative values, and so the stepping stone method is needed to find the minimum cost. And there are 3 negative values after calculating the empty cell, which is -5 in cell U1 and -1 in cell U4 and VD. So the value chosen is -5 because it shows the maximum reduction of the transportation cost. Okay, for the stepping stone method, the allocation to an empty cell will be conducted as shown in the table following the arrow that has been drawn. So for each of the cell in the flow will be written symbol of positive or negative. Following the symbol of negative and positive, the values in the cell of the flow will be added or subtract with the value in the second cell in the flow. Okay, so the result we get after added and subtracted can be seen in the second table, which is 3 in first cell of the flow and empty cell in the second cell of the flow, and 10 in third cell and 10 in the last cell. Okay, for the stepping stone method, the allocation to an empty cell will be conducted as shown in the table following the arrow that has been drawn. So for each of the cell in the flow will be written symbol of positive or negative. Following the symbol of negative and positive, the values in the cell of the flow will be added or subtract with the value in the second cell in the flow. Okay, so the result we get after added and subtracted can be seen in the second table, which is 3 in first cell of the flow and empty cell in the second cell of the flow, and 10 in third cell and 10 in the last cell. Okay, after the new value has been allocated in the cells, we will calculate the new total cost to find out whether the cost is reduced and can be minimized. So the new total cost calculated is $907. Therefore, the modified distribution method and stepping stone method is optimal solutions that have a minimum cost than the northwest corner method. Begitu.
Alright, for the conclusions, by applying transportation problem methods, our purpose is to establish an initial feasible solutions. We also to minimizing transportation costs and to reach the optimal transportation cost solutions. And the last one is to achieve the most cost effective and efficient distribution of goods.
Assalamualaikum, my name is Muhammad Faisal. This is a question 2. The question is, all this information can be presented by network shown below. So today we will find the critical path for each activity network. For answer the question 2, we will use critical path method or CPM. The critical path method is a mathematical technique used in operational research to schedule and manage project activities. It is particularly useful in optimizing the scheduling of activities to minimize the overall completion time or cost. So how we use critical path method? First is make a list of every project activity. Second one is determine which dependency exists. For the third, make sense of your result. For the fourth, estimate how long a task will take to complete. And the last one is determine the crucial road. Next is answer the critical path. Based on the question, we can see here the activity network. There are 6 activity network. I will list down each activity with its completion time taken to find the critical path. For number 1, A, B, C, D, G, H, and M. If we calculate, we will get 40 time taken. Next is A, B, C, E, H, and M. We will get 31 time taken. For number 3, A, B, C, E, F, J, K, and N. We will get 43 time taken. And number 4, A, B, C, E, F, J, L, and N. We will get 44 time taken. For number 5, A, B, C, I, J, K, and N, we will get 41 time taken. And the last, A, B, C, I, J, L, and N, we will get 42 time taken. For number 4, A, B, C, E, F, J, L, and N is a critical path with a maximum duration of 44 weeks. That's all for me. Thank you.
Assalamualaikum. My name is Muhammad Irfan. I will explain about the early start, early finish, let us start and let us finish. As you can see, each of the column at the left and the right top given in the equation. So you need to write back the first column from the early start. Must put 0 to get the early finish. We must add the number given with the early start. So 2 plus 0 equal to 2. So the early finish for column A will put in the early start and in the column B. So we will repeat the same process that we do in the column A. For the column C, E and F also repeat the same method. Before we go further, we look back into the column C. The column have 2 junction, I and D. So we focus on the column I first. So column I will do the same method as we did before the past column. Before we go through the column J, we must look where the source of the column J by looking the arrow. So the source from I and F, and then we need to choose the biggest yearly finish number. So in the case we choose 25 because the biggest number. Next, we do the same method like we do before. From the column J, have two junction, L and K column. For the early start column, L and K will take the early finish from column G before we go through column to the column, and we look where the source and the arrow, the source of from L and K, and then we need to choose the biggest finish number. So in the case we choose 38, the biggest number. After that, some operation to get the early finish for the column N. And now we look back at the column C again. We do the same operation until D and G columns. Before we go through column H, we must look where the source of column H by looking the arrow. So the source from E and G, we need to choose the biggest only finish number. So in this case, we choose 29 because the biggest number. After that, we must do some operation to get the early finish from column H, and then we do the same operation from column M. So that is the solution for early start and early finish. Need to find the letters. Next, to find the letter start and letter finish, we must put the column N and M letters finish 44 because the critical path is 44. So both column we do the minus operation that already given number as shown in the equation diagram. The next step we do the same operation for one arrow source only, but if the source come from the two arrow, we will choose the source from two arrow. We will choose the smallest number. From the example, column E come from the two source, which F and H. We choose the smallest number, which is 20. So continue the operation until column A, but the column split into the two source. We put the same number from the letters finish. So that's all for the solution for the to find the letters finish and letter start. Next is conclusion. Project management is critical for an organization to control. Using the CPN approach can optimize project duration by prioritizing key activities and reducing overall costs. Managing large-scale projects, scheduling and staffing individual activities across the organization in a step-by-step, priority-based way.
Ya. Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Haziq bin Abdul Hamid. Next is question number 3, and that is a topic about linear programming. So the question is, the manufacturers makes two types of toys, A and B. Three machines are needed for this purpose, and the time required for each toy on the machines is given below. Type of toys A and B. Machines for 1, 12.6, number 2, 18.0, and number 3, 6.9. So each machine is available for a maximum of 6 hours per day. If the profit of each toy of type A is 7 ringgit 50 cent, and that on each toy of type B is 5 ringgit. So show the 50 toys of type A and 30 of type B should be manufactured in a day to get maximum profits. So the introduction for linear programming. Mathematical programming is used to find the best or optimal solution to a problem that requires
a decision or set of decisions about how best to use a set of limited resources to achieve a state goal of objective. Okay, number two, steps involved in mathematical programming. Conversion of stated problem into mathematical model that abstracts all the essential element of the problem. Exploration of different solutions of the problem, and then finding out the most suitable or optimum solution. And lastly, the number three, linear programming requires that all the mathematical functions in the mathematical linear functions. Next slide. So the answer for the question number three, the answer is to solve the following LPP, linear programming, using products mix problem. So by the questions, we use the equation z, and that's its maximum z equal to 7.5 x1 plus 5 x2. So machine number one, uh, time required is A is 2 minutes, for B is 6 minutes. So the maximum time is 360. So the equation from the information given, we put back the information into the equation. So the formula, the equation is 12x plus 6y less than or equal to 360. The answer is 2x plus y less than or equal than 60. Then machine number two, time required for A is 18 minutes and B is 0 minute. So the answer is the equation is 18 x plus y less than or equal 360. The answer is x less than or equal to 20. So next slide. So just now for machine number two, now is machine number three. Time required for machine number three, for A is 6 minutes and then for B is 9 minutes. Okay, so maximum minutes for machine number three is 360. The equation for machine number three, 6x plus 9y less than or equal 360. So the answer is 2x plus 3y less than or equal to 120. So the answer from the all of the machine one, machine two, and machine three, we gather it and then turn it into the graph. Okay, so we draw first line X and then line Y, and then we put the information from machine X, and that is the first line between Y and X, and that is a line for 2x plus y equal less than or equal 60. And then line number two for machine number two is for x less than or equal to 20. And then line number three is for machine number three, and that is 2x plus 3y less than or equal to 120. So from the three lines, we can get the answer for the feasible uh, feasible feasible. We can find the part the 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 marked part for the answer, and that is A, B, C, D, and E. So there is 5 point from the line. So the first coordinate is for A, 0, 0. Coordinate B, 20, 0. Coordinate C, 20, 20. Coordinate D, 15, 15, 30. And lastly, coordinate E, 0, 40. Okay. So that is for the graph. Then after we finish drawing the line on the graph. Okay, we can conclude by using the equation maximize z equal to 7.5 x1 plus 5 x2. So we use back again the equation with the new coordinate. For coordinate A, z equal to 7.5 times 0 plus 5 times 0 equal to 0. For coordinate B, 7.5 times 20 plus 5 times 0 equal to 115. For coordinate C, 7.5 times 20 plus 5 times 20 equal to 215. For coordinate D, 7.5 times 15 plus 5 times 30 equal to 262.5. And lastly, coordinate E, 7.5 times 0 plus 5 times 40 equal to 200. Okay, next. So from the five coordinate answer, we need to choose the maximum value. Okay, so the most higher value or answer from the five coordinate is coordinate D, and that is 262.5. So conclusion for linear programming. Firstly, linear programming is a mathematical modeling technique designed to help managers in planning and decision making relative to resource allocation. Secondly, mathematical programming deals with solving optimization problems in constrained environment. A mathematical programming model consists of three components: decision variables, objective function, and constraints. The most widely used constraints mathematical programming are LP models. A LP model seeks to maximize or minimize a linear objective function to a set of linear constraints. That's all from us. Thank you.